In this video we're going to use triple integration to work out the volume of this solid. So here, this plane here is given by this equation, and then this curved surface here is given by this equation. So let's try and understand what this actually means. So imagine we've got a vertical sheet of paper here. So you've got your z-axis and y-axis. If I were to give you y squared plus z squared equals 16, you know you've got a circle of radius 4. And then if I were to give you, let's say, back in one variable, if I were to give you x squared here, it would look like this. But then if I apply this transformation 2, then you would squash it by a factor of 2. Well, here, if you apply 2 here, which would then give you a 4 here, that would mean you squash it by a factor of 2 in the z direction only. So really you've got an ellipse like this, where this is 2 and this would be 4. So that means this would be 2 and this would be 4. Okay, so remember we're only concerned about the first octant of this solid. So really this is like if you imagine the y-axis, the z-axis, you've really got yourself an ellipse here. So this would be -4, and this would be -2, and this would be 4. Okay, so the absence of an x in the first equation would mean you're going to get a trace in the x direction. So all these would be parallel to each other. You're going to get a trace in the in the x direction. So they're all parallel here. And then looking at this plane here, the absence of a z would mean that you're going to get a trace in the z direction. So all these would be parallel to each other. The absence of a z means you're going to get a trace along the z direction. So let's set up our triple integral to work out the volume. So V equals triple integration, and you can use whichever order you want. It will still work, but I'm going to use x dx dy dz. So in an integral, that means it's going to be x equals something, and then the next one would be y equals something, and then the last one would be z equals something. So looking at the inner integral, I'm moving parallel to the x-axis. So what that means is I'm moving parallel to the x-axis. So I'm moving like this. So if you look at this, I enter x equals 0, and then I leave that flat surface, this flat surface here. I enter x equals 0, and then I leave the flat surface. And then if you look at this, hang on, I would enter x equals 0, and then I would leave the surface. So I would enter x equals 0, and then I would leave this surface. Well, I need this surface in terms of x equals something. So I need to rearrange this equation to make x the subject. So that would be 4 minus y. So that's the first thing done. So now, hang on, let me clean this up. Hang on. So I've done x. Once I've taken care of x, the solid will collapse down to a 2D surface. So once I've integrated the x, once I've taken care of the x, the 3D solid will lose one dimension. It will lose the x dimension. So this whole solid will collapse down to this 2D flat surface here. Okay, so now looking at y, I need to move along the y. I need to move along the y axis. So what that means is I need to move like this. I need to move like this along the y axis. I need to move like this. So looking at the moving in the direction of y, I enter y equals 0 and then I leave this curve. I enter y equals 0 and then I leave this curve. I enter y equals 0 and then I leave this curve. Basically I need to know the equation of this curve. So the equation of this curve will be me making y the subject. So that would be 16 take away 4z squared square root. I get the positive version and the negative version, but I only care about the positive version. So well, I don't care about the negative root. So really, looking at this thing here, I enter y equals 0 and then I leave y equals this thing here. So I enter y equals 0 and then I leave the curve. I leave this curve. I leave at this curve, which would be root 16 minus 4z squared. And then hang on, let me clean this up. And then once I've taken care of the y, once I've taken care of the y, then I'm going to lose one dimension, the y dimension. So for example, I am currently looking at this 2D area. Once I've taken care of the y, then I'm going to lose a dimension, and this 2D area will collapse down to a 1D line, because I'm going to lose that y dimension. So now I'm actually integrating from, so now this whole area collapses down to a line. So now I'm actually integrating from z equals 0 to z equals 2. So I'm integrating from z equals 0 to z equals 2. So the volume is given by this thing here. So the volume is given by this thing here. Okay. I will continue in the next video. It's just a matter of us integrating this. Okay. I will continue in the next video.